Good afternoon, everyone.
Good afternoon.
I'll just start by saying, first of all, if I start to mumble, just shout, and if you have questions, wave, and I'll try to be careful to keep an eye open for who has questions as we go through. So the first thing is, I'm really delighted to be here. This is a fantastic opportunity for me. The timing couldn't be better. There's a lot to do in Parkinson's disease. There are a lot of challenges, and I know many of you who are here are all too familiar with the challenges. But there's so much going on in the research arena that I want to share how far we've come, some of the challenges, and what we need to look at, and what people are trying to do to meet some of those challenges and improve the future and the prognosis and the treatment options for people with Parkinson's. So, I call this Progress, Challenges, and the Road Ahead. Here we go. Oh yes, I'm holding it upside down, so it goes the right way now. That's it. So just so you get an idea of how I want to progress in this talk, I thought I'd start off with more of a traditional way of looking at Parkinson's disease, talk a bit about our current understanding and some of the recent advances that have been made. I want to look at some of the critical needs as we see them, and of course, importantly, we always learn so much from our patients, from people with Parkinson's, from the people who love them, the people around them, and so I'm always happy to hear questions and feedback. Then I want to get on to some of the Parkinson's disease research that's going on, and it's a really rapidly expanding field. I've been in practice here for almost 16 years now, and I've been in Parkinson's research for 20 years, and I think I can honestly say I have never seen the field so active. It's hard to keep up with all the new things that are going on, and luckily there are a lot more researchers who have come into the field. There's a lot more recognition of what needs to be done. And then the road ahead, and there's so much more to be done, obviously. By the way, on the upper right-hand side, you can't really read that very well, but it's from James Parkinson's essay from 1817, and he called it the shaking palsy. Now, as we know, not everyone with Parkinson shakes, but he was the first person to try to put all of this together. And it's always interesting to me because he actually recognized that it's not all about the movement, it's not all about the shake, that there are other symptoms as well. And I'm going to call that, in a slide coming up, the Parkinson's you don't see. So I think that's where we often don't do very well in our treatments. So this slide, this is the first time I have ever put any headline from the Daily Mail, which is sort of not really, it's a newspaper in England, but they were highlighting some of the recent data just about the sheer number of people who have Parkinson's. And there was a journal article that came out it was in the Lancet Neurology just late last year. And it has this map that you can see on the left-hand side of the slide. And it's kind of a heat map, if you like, of the incidence of the number of people who have Parkinson's. Actually, it's adjusted for the total number of people who live in that area. So when you're looking at the hotspots, I mean, look at North America, USA and Canada. And this is really an area in a region of the world where we see more people with Parkinson's, but proportionally more people with Parkinson's. And then you'll see areas where there are fewer cases of Parkinson's that are reported. And I think, obviously, there are questions about, well, if people are living longer in certain countries, there's going to be more people developing Parkinson's because it's very age-related. But this morning, I went to a talk from a fantastic researcher called Alison Willis, and she broke down the North American map, and she could show a sort of belt across North America where people are more likely to have Parkinson's. And whether that has to do with environmental exposures or what, we're not quite sure. But there's a lot of information in there, just in terms of figuring out why these patterns exist. But on the right-hand side of the slide, that I didn't really want you to be able to read this. It was just to remind me, as people have been looking at the number, as researchers have looked at the number of people with Parkinson's, they're seeing increases decade by decade. And it led to an article being published that was called The Parkinson's Pandemic, a call to action. And really it was kind of a call for researchers, for public health officials to sort of wake up and realize how serious this is. And we really have to get more resources into this field. So that was just a little bit of background. But now I want to go from the global and the national right down to the individual. And that's where I want to stay for a lot of this talk. So one of the things that strikes me in my clinical practice, and I think anyone who is in my specialty would say the same thing, no one person with Parkinson's looks like the next person with Parkinson's. And there are just so many different manifestations. There are so many different symptoms. There's so many things that we see on exam. They never quite fit together in the same pattern. Some of the things that we see in Parkinson's are just listed down on the left-hand side. And, you know, I put out pictures of three very famous celebrities, three very famous people who've had Parkinson's. And if you've seen them, they really have very different forms of Parkinson's. We see Michael J. Fox, for example, and he's very recognizable with the dyskinesia. Janet Reno, when I saw her years and years ago speaking, had her hand shaking at the podium, but really not many other symptoms at that time. So it's just so variable. But here are some of the things that we have to deal with. The tremor, the slowed movements, the incoordination, clumsiness. And we used to ask people about handwriting, and now of course nobody writes, so we have to ask about texting and typing and so on. But there's a facial expression, there's a change in the way people are perceived and the way that they communicate because of voice changes. There's trouble swallowing in some. There can be annoying build-up of saliva and even drooling. I think that's a very annoying aspect of it. And then something quite serious, the imbalance in the falls, because it just really takes one bad fall to have a bad injury that lands you in the hospital. And that's tough for us to treat. And then some people get freezing up with their movements as well. So these are the things that we see in Parkinson's. But I want to highlight, there's the Parkinson's that you don't see as well. And I think when I was a medical student, Parkinson's disease for us, it was all about the tremor, it was all about the slowed movement, it was all about the muscle stiffness. And as time has gone by, I think we realize that some of these other things that we don't see, they impact quite a bit more than the movement on some people. So some things like depression, anxiety, problems with thought processing, pain. And then the sleep. The sleep is absolutely fascinating. And my new best friends in the institution are the sleep docs, not only because they love to sleep, but also because there are particular ways that sleep gets disturbed in Parkinson's disease. And I put a picture of Alan Alda here because he had said he had this sleep disorder where he would act out his dreams. And actually that's something that I hear a lot about in my patients, and it's called a REM sleep behavior disorder. So in REM sleep, when you're dreaming, you have these really amazing mechanisms, these changes in the activity of various parts of the brain that will conspire to kind of keep you still, even though your brain is thinking that you're fighting or playing football or playing the banjo or whatsoever. And in Parkinson's, if those networks get affected, then it kind of releases the movement. People act out their dreams. So it can be dangerous. You can get injuries from it. But Alan Alda said that was a tip-off for him. He had read an article in the New York Times that I was part of that, but actually my colleague, I believe, Melissa Nirenberg, had brought up this question about this sleep disorder and it's linked to Parkinson's, and that kind of tipped him off. Outside of the sleep, there are all sorts of other problems that I've listed down the side, but we've got dizziness. Some people get almost into a faint. Yeah.
Going back to sleep, disruption of sleep. Typically, I don't know if others have nightmares.
Oh,
Those
yeah.
of us who have nightmares, the question is, are the nightmares caused by the Parkinson's or is that caused by the medication?
Oh, I'm going to answer the same way as I heard someone say hallucinations, and I realized going through this that I hadn't put them here.
Can you repeat the question?
Yeah, the question was, what about nightmares, and is that part of the Parkinson's, or is it part of the medication, or is it something else? I think for nightmares and for hallucinations, it's a mixture of the two. We used to say it was the medications alone, and now we think that there are various pathways in the brain that if the Parkinson's gets into those pathways, it can make people vulnerable either to nightmares or illusions. You know, the illusions when you might look at a pile of clothes on the floor, which I'm sure no one ever leaves them on the floor, but if, and then think, you know, the pile of clothes is an animal or something, that's an illusion. And then the hallucinations as well. So you can actually get those without taking the medicine. But I think the medicine just piles on top of the Parkinson's and makes people get more of these hallucinations and so on. Definitely nightmares, I've heard, as I've changed medicines with my patients, you'll hear nightmares get worse, nightmares get better. Sometimes it's predictable, but not always. But it's an interesting question.
Well, in the last few weeks, I deliberately stopped taking dope after 6 o'clock to see if it is.
Yeah, so the question is, if you're getting sleep problems, is it worth changing the medicines around? And I think not just for the nightmares, but sometimes the medicines can be a little activating at night. And then this comes down to the individual. And some people just sleep better if they have a little bit of dopaminergic medicine in their system. And I think that might be because they can move around a little bit better. So I think it depends on the individual. But all of those things are really worth bringing up and trying out. Because we can't always predict, but we can always do the experiment. So I mentioned the dizziness and then some of these other things. This is where Parkinson's genuinely needs a multidisciplinary approach. And I know we always say that for everything, but in Parkinson's you really do. So if there's sexual dysfunction, for example, if there's bladder problems, if there's constipation, we often will bring in specialists to work with patients and see what they can do to help. The loss of appetite. I love food, and to me that always seems like such a difficult thing for people to go through. And weight loss, and loss of sense of smell. So all of this, I don't know, it just adds up to a lot of things that impact on quality of life. So, I keep saying Parkinson's is really different between different people, and it's not just the types of symptoms and signs, and you know, I may see someone with Parkinson's and they have a lot of tremor, and then someone else won't really have much tremor. So it's not just that variability, but it's also like this variability in the time course. So I try to show here the time course where people would start with early Parkinson's and then go through moderate and later stages. And you know, early on we've got a certain set of symptoms, and then you start on the Levodopa medicine, and people get like these complications with the dyskinesia, the wearing off. And then later on, people get balance problems, which are difficult. But this rate of progression is just so different between different people. And I may have someone who comes in and we start following their course, and 10 years later they're doing great, and then someone else may come in, and just after a year they may need the Levodopa, they may already have dyskinesia. So it's really such a variable disorder. The question is, why is it so variable? And we are starting to think now, it's differences in genetics, it's differences in the areas of the brain that are affected in different people. And it's also, you know, you hear a lot about this protein called alpha-synuclein. I'm going to bring that up in a few minutes, but we always say that it's the hallmark of Parkinson's, that it's the protein where when the alpha-synuclein is damaged, that's what starts to impact on the brain cell function. But now we're finding that, of course, alpha-synuclein is a problem for the vast majority of people with Parkinson's, but there can be other proteins that are involved as well. And so the old way that we have of treating people with Parkinson's, which is kind of to focus on dopamine, and you brought up the dopaminergic medications, so that was always the mainstay. But now we're starting to think about, well, are there ways, like by using antibody treatments, where you can target specific proteins? Well, if we're going to do that, we need to know which proteins we've got to go for. And that just may be different in different people. And this is my team, before I go any further. So the people who help figure out all of this individuality and help to personalize the treatments, it's Natalie Helmers, our nurse practitioner, who's on the top. Harini Sava and Andrea Lee are my two faculty. They're both assistant professors, and they're absolutely fantastic. So that's the team. That's the clinical team. And then we have a research team as well. So the one thing that I've spent a lot of time going through so far is more or less to say Parkinson's is so variable. Well, why do we, quote, lump everyone together? I think in the past it's been pretty practical to do that, because the one thing that everyone has in common who has Parkinson's is they have dopamine loss in the brain. And that's it's been a really helpful thing to know, because really a lot of the symptoms, because they're due to dopamine loss, if we can restore the dopamine, if we can get dopamine back into the brain, we can help those symptoms. And I don't want to show you a lot of technical stuff, but I thought you might be interested in this. This is a scan. All these four pictures right here are from one person who got scanned. These four pictures are from someone else. And what you're seeing there, it's like if you've ever seen MRI pictures, it's almost like looking at a slice. I don't want to be gruesome, slice through someone's head. But what we're looking at is kind of like they slice it that way, right? And so the eyes would be right up at the front. Sorry, my shaking hands there. And then ears would be sort of to the sides there and there. And what we're looking at is where the red signal is. It's not dopamine, but that's the dopamine cells. Those are what we're looking at, where the radio tracer picks up, and it's bright red. This is where the ends, the terminals of the nerve cells that make dopamine, are actually delivering that dopamine. And this is someone who doesn't have Parkinson's, actually the wife of this man who does have Parkinson's. So I hope you can see the difference. Like, she's got a lot of red signal, and that's a lot of dopamine being delivered. And he doesn't have so much. And actually, he's doing great. He's compensating really well, and the medicines help. But there's just less dopamine being delivered. So this kind of shows you one of the reasons why this is one of the reasons why people seem to get slowing of the movement, they get some muscle stiffness, some incoordination, and that's the dopamine. And I just want to show you what happens. So this loss of dopamine going in, it's because of damage to cells that make dopamine. And when you look at the cells that make dopamine in someone with Parkinson's, they have like these little protein blobs in there, and that's the alpha-synuclein. So this is kind of our traditional understanding of what goes on with Parkinson's. And it's been useful so far, because if we think about what you need to do to replace the dopamine, it gives you all sorts of ideas for medications, and those are what have been developed. So we've got levodopa that the vast majority of people will take, and the levodopa, once you've taken the pill, gets absorbed through the stomach, gets into the bloodstream, gets up into the brain, and it's a one-step chemical reaction in the brain to go from levodopa to dopamine. So it works in a really simple way. And then there are a lot of other medications that have been developed, because dopamine's good, but it has some side effects, and we need other options. A couple of things that I wanted to bring up that are a little bit different. So I mentioned the levodopa. That's the carbidopa-levodopa, what's called Cinemet. That was the old name for it. And there are various different versions of that these days. We've got a whole bunch of drugs that we call dopamine agonists, but that's like pramipexole and ropinirole and rotigotine, and they're not chemically dopamine, but they look like they're dopamine to your brain cells. Amantadine can be helpful. Has anyone come across the Duopo pump? It's a pump. It's like a little cartridge. It's not quite like an insulin pump, but it's not far off that concept. It actually delivers the levodopa straight into the gut. It's not often used in my experience, but can be helpful. And then one of the things I'm going to come back to, because I just think this is so interesting, but it's the whole area of using surgery to help with movement and to help with Parkinson's. So I'm going to come back to that as a sort of equivalent to helping with dopamine loss. Okay. Oh.
What is it? I'm sorry.
What was the question? Oh. All right, so we talked about dopamine, but now I want to get more into the less traditional way of thinking about Parkinson's again. It's more than just dopamine. So Parkinson's is more than just alpha-synuclein, it's more than just tremor, it's more than just dopamine. And several years ago, there was a researcher called Heiko Brack, and he developed a kind of model of how he thought Parkinson's developed in the brain. And what he thinks is that it starts in places that don't cause movement problems. So he actually thinks that it starts in two places. And one of them is sitting right up here, and it's right close to the nose, so you lose sense of smell. And the other place is a little cartoon of a gut right there. So the other place he thought it could start would be down in the gut. And it could be large intestine, small intestine, but he thought that was where the Parkinson's might begin. So we know now, for example, that before a lot of people get Parkinson's, either they can lose a sense of smell, or they can get constipation. So it doesn't help us with the treatment right now, but I'm going to come back to that because it might help us to identify Parkinson's earlier. If we can start to put together some of these things that will happen before the traditional tremor and coordination issues that help us to identify Parkinson's. So let's think about how we can do better. These are just some of the things that there's so much going on in the Parkinson's world right now. These are some of the things that I wanted to bring up that I think are important, but there's obviously so much more. We're just scratching the surface. I thought diagnosis is one issue. Early on in Parkinson's, we may misdiagnose, we may be slow to diagnose. There are certain conditions that can look like Parkinson's right at the beginning. Progressive supranuclear palsy, multiple system atrophy, dementia with Lewy bodies. A lot of these, we make mistakes and we need to do better. And we're not diagnosing early enough. The second thing is, and this is coming back to that idea where everyone is so different, I think we need to do a better job of giving individualized advice and individualized therapy. And right now, if you see a neurologist and if you see a Parkinson's specialist, we'll use our experience to do that as best we can. Wouldn't it be great if we had more of a precision medicine approach where we could get data either from your genes or from the proteins in your blood or from, I don't know, let's say tracking the way that you move. Wouldn't that be great if we had some data to work with? We need to give individualized therapy to get the right treatment to the right person for the symptoms, but also to be able to slow down changes in Parkinson's, and I'm going to call that neuroprotection. But we need a cure, right? I mean, that's what is actually needed. And since I brought up the genetic contribution, we also need to think not just about the person who's got the Parkinson's, but who's in their family and what does it mean for them in practical terms and who's going to help, but also what does it mean for the family members when you have Parkinson's running in your family? And are there things that you could do to reduce your risk of getting Parkinson's if you're in a family where it seems to run? Okay, So let me just mention a couple of things about the diagnosis, and I can see already that I don't have a good picture here, but we're gonna, this is a Macintosh to PC problem. All right. In the clinic, we know that in early Parkinson's, we may be unsure that it's Parkinson's, and then the question is, what do you say to the patient in front of you? Do you worry them, or do you say nothing, and then you're not giving them all of the information? So there's often a period of uncertainty. Do we say what we think it looks like? It looks like Parkinson's, but then we stand a risk that it might be something else. It could be multiple system atrophy. So again, we're working with our clinical experience, but it would be really great to have better tests and better data. So the scans can really help us do that. And if I click back, there we go. This sort of scan can help us to diagnose Parkinson's. In fact, this can probably diagnose earlier than a physician can, using our clinical experience and our clinical acumen. So the scans are great, and just for your interest, the radio tracers, the radio tracers that we use are all related to cocaine. For the simple reason that cocaine binds onto your dopamine neurons. So they say it would take 10,000 doses of the radio tracer to get a buzz. But I just thought that it's kind of an interesting thing. The brain MRI, by the way, won't diagnose Parkinson's the way that we use the standard MRIs, because you just don't really see structural changes that we can use for diagnosis. But this sort of PET or SPECT scan can be helpful. But it means when you get that scan, you've got to have an injection. It's a radio tracer, so you're getting a little dose of radiation. They're expensive, and not everyone has access to them. So we all think it would be much better if we could develop a blood test, obviously. And that's what people are trying to do. The Michael J. Fox Foundation have really led the way here. And they realized very quickly that if we're going to develop blood tests or spinal fluid tests or tests of urine that are going to diagnose Parkinson's, we need to get together a whole bunch of people who have Parkinson's and start examining their blood and their spinal fluid. So this is a study that we participated in. We were one of the lead sites in this study, and it's called BioFind. And the whole aim was to get 120 people with typical Parkinson's and 120 people who did not have Parkinson's. And then you just gather all this data, and we would gather biosamples, including spinal fluid. So for anyone who ever contributed their spinal fluid, a hearty thanks, because that's really helping push the field forward. But basically, this study helped to provide researchers with clinical data with blood, with DNA, the genetic material, the RNA, and spinal fluid. And not only can these samples then be used for what we call validation, or kind of cross-checking, if researchers think that they have a promising test, but it can also be used to start to develop new tests. And that's really moving ahead nicely. And this is a national effort. So I just put up this map here. And I'm not sure if you can see very well, but the sites were spread across the country. And that was an amazing team to work with. So we're not there yet with the blood test, with the spinal fluid test, but making some progress. So it's a very interesting field. What about genetics? When I trained, we never really thought that genetics was going to be the way ahead in Parkinson's. We just thought so few people have Parkinson's running in the family. It's something like 3 to 5%. But it turns out that there's a whole bunch of genes that have been identified where mutations seem to cause Parkinson's. But for a lot of people, there are probably genes that don't give you Parkinson's, but they're a risk factor. And if you get enough of those risk factors all building up, it may be enough to cause Parkinson's. So the genetics, it's not like what I learned at high school. It's really become way more complicated. But what I wanted to do here is just highlight the genetics we can't use in the majority of people yet for diagnosis. But if you have a family where there seems to be heritable Parkinson's, and someone comes in and they say, hey, you know, I slowed down a little, I don't know if it's arthritis or what. There, potentially, we could start to look at using a genetic test. Some of the genes that are really being intensively looked at right now, there's a couple of them, because for people who have these forms of Parkinson's, the NLRK2 and the glucose cerebrosidase, the GBA, it looks like these may be the first where we could actually get treatments that are specially for people with those genetic forms of Parkinson's. I'm going to come back to that at the end. All right. The other thing before we move on from diagnosis is, I already said, even when someone first comes in, if the symptoms are mild, it can be hard to diagnose. And we make mistakes. And that's not good enough. But we should even be thinking more than that, right? We shouldn't be waiting until people are worried enough that they're coming in and say, hey, I was reading online and, you know, my handwriting's changed, and what do you think? We should be finding problems earlier so that people can get proactive, and so that as we develop treatments that could slow down progression, we could intervene earlier. We're not the only group to think this. There are several groups across the globe who are trying to see, could we diagnose Parkinson's before tremor, before movement problems, before incoordination. So this is what I called here pre-diagnostic stage. Remember I talked about the sleep problem before, and I talked about people who lose a sense of smell with Parkinson's? It can begin with that. And so one possibility is that if we figure out who, out of the people with the sleep disorder, are at high risk for going on to develop Parkinson's, we could start to see, is there something we can do with those people to prevent the development of Parkinson's? So there, we're talking about starting to develop preventative treatments. That's really where we want to be. I think it's going to take a while, but we're heading there. The premotor symptoms I just mentioned briefly, and this is my sleep colleague, Dan Barone, who's fantastic and wrote a brilliant book about sleep. What are the premotor symptoms? Why are they important? Well, I mentioned the REM sleep disorder, so people who act out their dreams. We are now following people who act out their dreams. We're just trying to follow along with them over the years and see, does something else develop? And would we ever be able to predict who might go on to develop tremor, to develop Parkinson's, to develop cognitive problems? So that's a whole big study that we're doing. And there are other groups across the world who are doing that too. Okay, so now I think I'm going to move on from the diagnosis, and let's get to the meat of the talk, because this is about the treatments and what's new, what's coming up, and what we might be able to do better. Okay, so here we go. Where do we stand with treatment right now? For anyone who knows me, I'm going to sound like a broken record. The foundation, number one, exercise, exercise, exercise. So I honestly think that people who can stay active, and exercise can be running and biking, or exercise can be sitting down and doing breathing exercises. I mean, all of this is good. I really think that it helps. We think it may have some fundamental effects on the brain. It certainly does in animals, but we don't know exactly what in humans. But I just put a few examples here where it's been shown that particular exercises have helped people with Parkinson's. Tango. There's a picture of a fantastic group in Brooklyn. These guys, the Dance for Parkinson's Disease group, and they're now worldwide. And I think they help people in very many ways. My first project when I came to Cornell was a Korean energy yoga class that we used to hold for people with Parkinson's, and that was absolutely amazing. So we think these help particular symptoms. The question is, do they actually slow down progression? So I will say a lot of us in the field feel that exercise does slow down progression of Parkinson's, but it's not proven. And it's not proven whether there are fundamental changes in brain structure, but oh my gosh, it's the data is very intriguing. Foundation number 2,
I have a
eating.
question.
Yeah.
With exercises, are there various forms that are considered better, like aerobic exercise?
Oh my gosh, that's a fantastic question. So the question is what would be the best exercise? I think, honestly, it's different for different people. And it may be different for different symptoms. So, for example, Tai Chi has been studied as a way to improve balance. Dance has been studied as a way to improve movement as a whole. But then when you start breaking down who benefits and who doesn't benefit, it may be that there are some differences there. So in my clinic, we treat it as a very individualized thing. I think you also have to want to do the exercise. So for someone, it may be dance, because that's a beautiful thing to do and it's social. And someone else, like me, may have 2 left feet, and I that would be torture for me, and I would rather be on my own and do yoga. If you're comparing whole categories of exercise, like is it better to do aerobic or is it better to do stretching, I think the data is actually a little bit contradictory. And so what I try to get people to do is a mix, everything in moderation. So some aerobic, some stretching, and I think something against resistance is really good, whether it's water exercise or whether it's using light weights. But if you look through the literature now at the types of exercises that are shown to be beneficial, it's so broad-ranging, it really is. Walking, stretching exercise, all of these have shown benefit in certain people. I guess it's something where we don't understand enough yet to really be able to individualize that. So I thank you. I think that's a really great question. The eating, I'm going to sort of generalize a little bit on this as well. So we know there's such a thing as eating for healthy aging, and we know that cleaning up our diets can help us all feel better. But there are a few specific things in Parkinson's. A good colleague we were residents together, Nick Scames, he's actually spent a lot of his research career studying the Mediterranean diet, I think because he's Greek. But he's shown that adhering to a more Mediterranean style of diet with olive oil and not butter, and with whole grains and lots of fresh fruits and fresh vegetables and fish 3 times a week, this kind of very nice diet, not only seemed to be associated with a lower risk of getting Parkinson's, but also seemed to be associated with slower progression of Parkinson's. So there's something there that we need to understand better. And then there are all the obvious things, of course, like staying hydrated and getting adequate fiber, timing of food, particularly protein around the medications. So there are lots of practical things that can be done. And one thing I haven't put on here are all the supplements, because there are just so many that have been studied, that are being studied. But we can come back to that in questions if you like. So let's get to this is a more traditional way of thinking about Parkinson's treatment. And unfortunately, when you have Parkinson's, you do sort of end up needing to take medicines for the most part. And there are a lot of medicines that have been approved for a long time. And carbidopa, levodopa has been around since the 1960s. But there's a whole bunch more. Some of them, like the Rytari, are still based on carbidopa, levodopa, but it's a different formulation, and for some people, it seems to work better. There's that Duopa infusion, which is also based on carbidopa, levodopa, and for some people, seems to work. We had sulfinamide come out recently. We had the extended release amantadine. And I'm not sure whether you've been following, but we're just getting this inhalable carbidopa, levodopa. It's like a little inhaler that you put in your mouth, and you can get a rescue dose. It's supposed to kick in pretty quickly. So we just yesterday got the order forms that we can order it for the first time for our patients. So it really is that new. In the testing pipeline, there are way too many things to put on a slide. So I highlighted several. the antibody therapies I highlighted because this is such a new way of looking at treating Parkinson's. And there are 2 clinical trials right now that are looking at anti-synuclein antibodies. So I think those are going to be really interesting. Nilotinib, you've probably heard a lot about. That made a big splash in the press. It would have been a couple of years ago in a very small study. That's a cancer drug that now is going into more testing for Parkinson's. And Neuroderm, it's like a patch. It's got a little needle that goes under the skin, and that's going to deliver carbidopa, levodopa as well. So that's maybe something that could be helpful for a lot of people. That's just going into testing. And then many, many more. So then, I wanted to mention the surgical treatments because I think over the last few years there have been huge advances in the way that we use surgery for Parkinson's. And the use of deep brain stimulation surgery has been around for so many years at this point. I mean, it was just starting when I was coming out of training. It's incredibly helpful for people when medicine isn't working as well as it should. So if the medicine's coming on and then wearing off and on and off, or if people need more medicine but can't take more because of dyskinesia, not everyone would benefit enough from the surgery to make it worthwhile, and there are risks that go with it. But for some of my patients, it's been an absolute game changer. And I want to bring up just the last few years, I think we've been able to individualize a lot more. Now, we know a lot more about where we should, how to choose between different targets in the brain so that we can start to individualize based on people's different symptoms. It helps reduce the off time, it helps increase the amount of good function in the day. And in a lot of people, they manage to reduce their medicine. But now people are starting to look at, well, hey, could we use it to improve balance? And that, we always thought that was not really going to be the great strength of the surgery. But now there are different ways of doing it that may be helpful. There's been a lot of discussion as well about when to do the surgery. When it started, it was almost like a last resort. And then we started doing it a little bit earlier and realizing that it was helpful. And there was a study in Europe where they said, well, let's go earlier still. When, strictly speaking, people didn't, quote, need the surgery. They could have managed longer with the medicine. But actually, they found that there was a kind of tipping point where if you jumped into the surgery at that tipping point, you would actually do better in terms of quality of life. So there's a lot of discussion about how early should that be. And it's still not really for early Parkinson's disease because of the risks that go with it, but earlier than it used to be. And there are just a lot of new advances in the hardware, the types of leads that are used, the software, the way we do the programming. It's really changed a lot. But more than that with the surgery. This, I think, is exciting. This is kind of a surgery without drilling, without cutting, without incision. I wouldn't say it's non-invasive, because what the surgeons are doing now, Dr. Kaplan here is leading this effort, and he's probably got more experience than most people in the US at this point. It's something called MRI-guided focused ultrasound. And the whole idea is that if you have many, many beams of ultrasound, an individual beam of ultrasound won't hurt the cells in your brain at all. But if you've got enough of them and they all focus in at one point, you can actually zap, you can kind of burn a small area of cells out. So this is based on the fact that in Parkinson's, I've been talking about dopamine loss, but what I didn't talk about is that some of the problems are from a whole set of cells in a very tiny area that are hyperactive. So if you can decrease their activity, you can help to control the Parkinson's symptoms, movement symptoms. And that's kind of what the deep brain stimulation is based on. So right now, it's incredibly experimental in Parkinson's. It's FDA approved for essential tremor. People have tried it for Parkinson's for the tremor, but it's only recently that we've been studying it for all of the symptoms, the movement symptoms of Parkinson's, like the slowing and the incoordination. And Dr. Kaplan has now performed this procedure on 5 people. And again, when I say procedure, It's not cutting, it's not drilling, but it is invasive because it does involve zapping a small number of cells in there. So I just thought that was a really amazing advance, and it's in testing right now.
Does that stop the progression?
That is a great question. Like deep brain stimulation, we expect that the ultrasound will hold the symptoms that it works on, like the incoordination, or if people have dyskinesia, that it would hold those at bay. The problem is that it's not going to stop progression elsewhere in the brain. So let's say you'd have that procedure, it helps the movement, but it's not going to protect you from maybe later getting problems with blood pressure, or later getting problems with hallucinations, or later getting more sleep problems. So that's actually I'm going to come back to that actually, because that's a huge problem right now. I think we're targeting particular areas, but what we need to look at is the whole. I'm going to show you one way of doing that though. So some of the remaining challenges. The movement control, we probably do better there than we do with anything else, but we still don't do well enough. We need to help people with the ons and offs of the medicine. We need to help with the dyskinesia. We need to help with the balance, the speech, the swallowing. For the non-movement related symptoms, depression or memory loss, things like that, you know, we can treat, but we really seriously need to do better in those areas. We could do better in earlier diagnosis. We could do better telling people what's going to happen to them. We don't know how to predict the course right now. And we could do better in terms of being able to slow down those changes as well. And then I think the big ones have got to be finding a cure and eventually preventing Parkinson's. And I think that some of the limitations that we have to do with us all lumping people together and saying, okay, you have Parkinson's, that's what we're going to call this, and we're not going to break it down any more than that. So I really do think we need a precision medicine approach. And here at the bottom of this slide is one example. So Mike Caplet, you already heard me mention him in terms of, he's our neurosurgeon who takes care of our patients if they need surgery. Well, he was also the first person to perform gene therapy for Parkinson's in the world. And the way that he did that was he introduced genetic material, foreign genetic material, using little crippled virus that sort of looks like that. And you can inject it into a specific area of the brain. It gets taken up. The genetic material, the DNA, gets treated like it's your own brain cells, DNA. And he could reprogram cells. And you remember I said there's a little area with hyperactive cells. He could reprogram them using this genetic therapy, gene therapy. He could reprogram them to take away the hyperactivity and the hyperstimulation that they were giving. So that kind of opened the way to the rest of the research field. And now there are many different groups who followed his lead and tried to do this in different ways. But one that I wanted to bring up, because again, it comes down to how can we individualize? And although it's only the very first, like a little baby step, one way we can individualize is with people who have the genetic forms of Parkinson's. So there's interest now in being able to use this approach, not to reprogram a small number of hyperactive cells, but to actually reprogram cells that have a genetic problem that is the root cause of Parkinson's. And if we could do that, that would get us into the whole brain, not just a small area. And so conceivably, that could prevent future progression. It could turn the whole thing around. Incredibly early days. People are just starting to think about setting up these trials. And then just last 2 minutes, I wanted to bring up something that, so obviously we work with Dr. Caplet, and then a final surgical approach, which has been tried years ago, but with recent advances in stem cell technology, we feel that we have a good reason to try regenerative medicine approaches for Parkinson's again. And the idea of regenerative medicine is, if you remember those scans that I showed you, and I said, well, look, you know, where the signal, where the radio tracer signal is not as intense in someone with Parkinson's, and it's because you've lost some of the dopamine inputs, some of the cells are damaged, why not replace them? This is an idea that has really been around since the 1980s, and the initial clinical trials started in Sweden, in Lund in particular, and they had a big program where they figured out how to do cell transplantations. They figured out a lot of the difficulties, and they figured out some of the side effects. But the fact is, they were not able to use the cells that we have available now. They were using a mix of human embryonic cells, whereas now we have the possibility to grow unlimited numbers of pure stem cells in the laboratory. Not only can we grow unlimited numbers, but if you work with someone like our collaborator, Lorenz Studer, who is just genius at this type of work, he figured out how to take the stem cells and kind of coax them in the laboratory into becoming dopamine-producing cells. And in his hands, or in the hands of his remarkable team, the cells, as they grow them, they look identical to the cells that we have in our brains that make dopamine. And so we're now planning, with support from a company who are going to fund the first trial, we are now planning to try to transplant those into the target areas in the brain of people with advanced Parkinson's, and these we hope will be able to deliver dopamine to the area in the brain that needs the dopamine. So what I'm showing you here is just this idea that we can grow the cells in the lab. The lovely thing is, when you've got all of these cells, you can freeze them down, and then you've just got them sitting there for as long as you need to do all of the testing that you need to do and figure out the purity and figure out, do they do what they're supposed to do? Do they produce dopamine? Do they survive the freezing nicely and all that kind of thing? And then what will be the final step will be, hopefully later this year, that we'll be able to, using a surgical approach, get those down into these deep areas of the brain where the dopamine is lacking because of Parkinson's. Again, going back to your question about the previous surgical approaches, this isn't going to stop the progression of Parkinson's, and it's only going to tackle one area of the brain. The question is, what can be done later down the line to help with some of the other issues in Parkinson's? And this is our timeline, and we've been through this planning and manufacturing and production, and we're heading now for the clinical trial hopefully soon. And this is just an amazing group of people that I've had the pleasure to work with. This is Lorenz Studer, Vivian Tabai, who's going to be the surgeon leading all of this, but an amazing team. And we're not the only group who are trying to do this. So for anyone I'm not sure if you noticed last year in the news, the Japanese group in Kyoto actually did their first surgery on someone with Parkinson's. They just operated on one side of the brain. Apparently the surgery went well. We presume that things are still going well. We haven't heard. We're due for an update shortly. And what we are trying to do with these groups across the globe is that, in contrast to people competing and just doing things their own way in the past, we couldn't even compare different teams' results. What we're trying to do now is stay harmonized. Here's the group. They're from really across the world. A lot of these people are in Europe and also Japan and the US. And we're trying to make sure that although we will be using different cell types, we are competing, obviously, but that we're looking at similar types of Parkinson's, that we're looking at similar types of testing afterwards, using similar types of scans. So we'll be able to compare results, and it's really going to move the field ahead, we think, a lot faster than we could do otherwise. And the name of this group, we even have a logo, the name of this group is G-Force, Global Force for Parkinson's. So we all have a common aim, which is to get a new therapy to people with Parkinson's. So
just to summarize then finally, I think there have been some really amazing advances since I was in training. We understand so much more about the genetics, we understand so much more about how variable Parkinson's is from person to person. There have been quite a few new drug treatments, and then the deep brain stimulation and expanding its applications and doing better with that. And then I think we have a lot more appreciation now about exercise and diet. When I was training, there were still doctors who would say to patients, you don't need physical therapy, it's not going to help you, you need medicine. And now we've sort of done the flip on that. More advances are currently in testing. So improved medicines, the antibody therapy I brought up, gene therapy is really ongoing in several different groups. The MRI-guided focused ultrasound, which is called Exablate, the cell therapy, and then I just put here some of the challenges for the roads ahead. But I think I've said these before, you know, we need better diagnosis, we need neuroprotection, we need a cure, we need better treatment of the non-motor symptoms. You've heard what I said before. So we've come a long way. There's a ways to go. And I just want to show you my team, and I put them all on a brain here. And I chose this picture of a brain because it's, I think it's from the late 18th century, and it was just when they discovered the substantia nigra, where the dopamine cells sit in the brain. This person who drew this was actually the anatomist who discovered the substantia nigra. So is, whoops. These are my team right here. We're sort of sitting close to the midbrain. And then we also are very lucky to have, like I mentioned, our sleep specialist. We work with someone, I didn't show his work, but Fei Wang is a fantastic researcher who works on deep learning and machine learning. And he can take big data and try to break it down and see what subtypes there might be in Parkinson's. These are some of our research coordinators right here, and guests. And then we're very lucky to work with people who specialize in memory and nutrition, and right here, Dr. Palajani specializes in autoimmune disease. I didn't mention it, but there's a whole idea now about inflammation and how important that could be in Parkinson's, so she's really great to have on our side. And keep going backwards, there we go. So last slide, I just wanted to acknowledge the people who fund us. And we've, the lovely thing about working at Weill Cornell is we have fantastic collaborators from across a number of different departments. So they help us with the scans, they help us in every possible way, not just take clinical care of our patients, but also with the research. So I'm going to stop right there and I'll take questions. Thank you.